Welcome. In this video, you'll learn about mutually exclusive events and solve probability problems involving these events. Mutually exclusive events are events that cannot occur at the same time. For example, it's impossible for you to be holidaying in a cruise ship and at the same time be skiing in the Swiss Alps. The event being in the cruise ship and skiing in the Swiss Alps are mutually exclusive events. Similarly, when you roll a dice, you can either get 1 or 2 at a time. We cannot get 1 and 2 at the same time. Therefore, the event that the dice lands on 1 and the event that the dice lands on 2 are mutually exclusive events. When you spin this spinner, you can either get yellow, blue, or red. Suppose that you spin the spinner, the probability that the spinner lands in yellow is 2 out of 5, as there are 2 yellow areas out of 5. Similarly, the probability of getting blue is 2 out of 5, and probability of getting red is 1 out of 5. The event that spinner lands in yellow, lands in red, and lands in blue are mutually exclusive. Spinner cannot land on yellow, blue, and red at the same time. Spinner lands on either yellow, blue, or red at a time. Sum of the probabilities of all the mutually exclusive events always add up to 1. In general, if A and B were 2 mutually exclusive events, then we can say the probability of A plus probability of B is equal to 1. Similarly, we can extend this rule to many different mutually exclusive events. For example, if A and B and C were 3 mutually exclusive events, this would be probability of A plus probability of B plus probability of C is equal to 1. When we spin this spinner, we know that the probability of yellow is going to be 2 out of 5 since there are 2 yellow parts out of the total 5. However, there are 3 parts that are not yellow. Hence, the probability of not yellow is going to be 3 out of 5. We usually write this with a bar on top of y or little dash to denote it's not yellow. It's also sometimes known as complement of y. But notice that the probability of yellow and probability of not yellow, they add up to 1. Sometimes if the probability of yellow is unknown but the probability of not yellow is known, then we can rearrange the equation to find the probability of y, as these 2 events are the exhaustive list of mutually exclusive events. So in general, if A is an event, then A dash represents the event that is not A. They are mutually exclusive event and always add up to 1. If the probability of an event A is known, we can then find the probability of its complement by rearranging the equation or taking away from 1. When you spin this spinner, let's say the spinner does not land in yellow, then it must either land on blue or red. So we can write probability of not landing on yellow is equal to probability of red or blue or red, whichever way you prefer to write this. The notation for the or is the union symbol. So we can write probability of red or blue is equal to probability of red union blue. The probability of not landing y is therefore can be found by adding the probability of landing in blue, which is 2 over 5, and probability of landing on red, which is equal to 1 over 5. So together this is equal to 3 over 5. Since the probability of not landing on yellow is equal to probability of landing on red or blue, and it's also equal to probability of landing on red and probability of blue, this implies that the probability of landing on red or blue is equal to sum of the probability of landing on red and probability of landing on blue. In general, if 2 events A and B are mutually exclusive, we can write this as probability A union B as equal to probability A plus probability of B. In fact, this rule is true of any number of mutually exclusive events. For example, if there was a third event C, which is also mutually exclusive events to A and B, then the probability of A, B, or C is going to be equal to probability of A plus probability of B plus probability of C, and so on. This is known as the OR rule of probability for the mutually exclusive events. Whenever you see the word OR in the probability question, it means we can apply the OR rule. So watch out for this keyword in your question. 4 athletes, Aaron, Bob, Carl, and Smith, take part in a race. The table shows the probability that Aaron, Bob, and Carl win the race. In part A, you got to find the probability that Aaron will not win the race. And in part B, we need to find the probability that Smith will win the race. And in part C, we need to find the probability that either Aaron or Bob will win the race. And in part D, we need to find the probability that either Aaron or Bob or Smith wins the race. So Aaron winning the race and not winning the race are mutually exclusive events, as he cannot win and not win the race at the same time. Therefore, they must add up to 1. Since the probability of Aaron winning the race is given, we can find the probability of him not winning the race by subtracting it from 1, which gives 0.7. Similarly, in part B, we need to find the probability that Smith wins the race. Smith winning the race and losing the race in this case is also mutually exclusive event. If Smith is losing the race, then either Aaron, Bob or Carl wins the race. Therefore, the probability of Smith does not win the race is given by adding 0.3 plus 0.25 plus 0.28. Subtracting this from 1 will give us 0.17. This is the probability that Smith wins the race. In part C, we got to find the probability that either Aaron or Bob wins the race. Events that Aaron wins or Bob wins the race are actually mutually exclusive events, as the race can be won by Aaron or Bob at a time. There cannot be two winners at the same time. So we can use the OR rule and add the probabilities to give 0.55. For part D, we need to find the probability that either Aaron or Carl or Smith wins the race. These events are also mutually exclusive. Therefore, we add the probability of Aaron winning the race with the probability of Carl and Smith winning the race, which was calculated in part B. This together will give us 0.75. Here is the example for you to try. Please pause the video and have a go at it before checking your answer along with me. A bag contains red, white and yellow balls. A ball is taken from a bag at random. Probability of taking white ball is 0.3. The probability of taking red ball is 0.24. What is the probability of taking red and yellow ball? In this exercise, notice that the action of picking the ball from the bag occurs at random. So any one of the ball has equal chances of being picked. However, there are more white balls than red ball, so that the chances of picking the white ball is higher than the red ball. So if we let W be the event that white ball is picked, then from the question we know that probability of W is equal to 0.3. If we let R denote the event that red ball is picked, then it's given to us in the question that probability of R is equal to 0.24. And finally, let Y be the event that yellow ball is chosen. This probability, however, is unknown. Each of these events are mutually exclusive events. When you pick a ball at random, you either get red, yellow, or white ball at a time, and you'll never get two colors of the ball at the same time. Therefore, the probability of all these events should add up to 1. And the probability of getting yellow ball then can be found by subtracting the probability of getting white and red from 1, which gives us 0.46. Getting red or yellow ball are also mutually exclusive events. So in this case, we can use the OR rule and add the probability of getting yellow and red ball, which is then equal to 0.7. Here is another example for you to try. Please pause the video and have a go at it before looking over to the solution. Some red, blue and green counters are numbered 1 and 2. The table shows the probabilities of obtaining each number and color when the counter is taken at random. A counter is taken at random, and in part A we need to find the probability of taking a red counter. Red counters are either numbered 1 or 2. Counters can be red and number 1, or it can be red and number 2. These two events are mutually exclusive. They cannot occur at the same time. It's not possible for you to pick a red counter and which is also number 1 as well as 2 at the same time. If we let R be the event that the red counter is picked, then we can find the probability of picking of a red counter by adding the probability of red and 1 with the probability of red with 2, which is equal to 0.4. In part B, we need to find the probability of taking a green counter. If we let G be the event that the green counter is chosen, then the probability that it's green and 1 and probability that it's green and 2 are mutually exclusive event. In order to find the probability of green, we can add the two events together, which is 0.1 with 0.3, and this will give us total of 0.4. In part C, we need to find the probability of taking green counter or number 2. Probability of getting green counter is given by adding the green column, which is also the answer to part B of the question. But we must also include the probability of getting the counter with number 2. This is the same as the row total of 2. However, note that we have already included the probability of getting green and number 2 on the counter when we found out the column total. Therefore, we must subtract this probability from the table, and this will give us 0.7. In part D, we need to find the probability of taking blue counter or numbered 1. This is similar to part C and given by adding the blue column with number 1 row total and subtracting the probability of getting blue and number 1, which gives us 0.4. Similarly, in part E, we need to find the red or number 1. This is given by adding the red column with number 1 row total and subtracting the probability of getting red and 1. This gives us 0.7. If you find this video useful for you, please click like. If you think someone else can benefit from it, please share. And if you want to hear from me again, please do not forget to subscribe to my channel. Thanks for watching. Be sure to try the exercises to test your knowledge. I'll see you in the next part.